Today we're going to talk about the polygon angle sum. And we're actually going to do like a little activity, and I'll kind of walk you through it, to derive this formula to figure out why this works and why the formula is what it is. So first it says, what is the sum of the measures of the angles of a polygon shaped like a stop sign? You can find the answer by drawing diagonals from one vertex of the polygon. Okay, so I'm going to pick, it does not matter, this one. And I'm going to draw a diagonal, and I'm going to connect to every other vertex. So this one, here, 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 and then if I went that way, it would just go straight. So it says the diagonals form blank triangles. How many triangles did this make? 1, 2, 3, 4, 5, 6. The sum of the measures of all the angles of a triangle is how many degrees? What did we learn when we talked about triangles? How many degrees are in, if I were to add up the angles of every triangle, every single time, it's going to be 180 degrees. So what we can conclude is that this octagon, right, this stop sign is made up of 6 triangles. So I should be able to do 6 times 180, which is 1,080 degrees. So if I were to add up all these angles, it would be 1,080 degrees. So what I want you to do on your paper is it says to draw polygons with 4, 5, 6, and 7 sides. Then draw all the diagonals from one vertex of each figure. Count the number of triangles formed, and then we're going to find the sum of all the angles. Okay, so pause it, do what we did up here, but do it with a 4, 5, 6, and 7-sided figure. Okay, your figures do not have to be beautiful. Your 4-sided figure, right? I'm picking one vertex, drawing a diagonal. So it formed 2 triangles. So 2 times 180 is 360. Okay, let's go ahead, and if I had a 3-sided figure, how many triangles did it make? 1, because it's a triangle. So that's 180. Okay, let's draw a 5-sided figure. 1, 2, 3, 4, 5. Okay, I'm picking this diagonal, and I'm going to go here and here. How many triangles did that make? 3. Each one is 180 degrees. So that's 540 degrees. What if I had a 6-sided figure? Okay, like this. 1, 2, 3, 4, 5, 6. So I'm going to start here, draw my diagonals. How many triangles did it make? 1, 2, 3, 4. 4 times 180 is 720 degrees. And then a 7-sided figure, I'm real bad at these, but that's okay. 1, 2, 3, 4, 5. Let's just go 6, 7. Okay, it looks janky, but that's okay. So I'm going from here, and I'm going to go here, 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 and here. So that's my 7-sided figure, and it made 1, 2, 3, 4, 5 triangles. And that's 900 degrees, right? And then we could even write in if we wanted to, because up here we did an 8-sided figure. It made 6 triangles, which was 1,080 degrees. So on number 3, it says, describe how the sum of the angle measures changes as the number of sides of a polygon increases by 1. So as our number of sides increased by 1, what happened to the sum of the angles? It went up by 180, right? Every increase of one side added 180 degrees to the sum, right? I added a side, I added 180. I added a side, I added 180. And so part B says, what relationship do you notice between the number of sides of the polygon, so that's this first column, and the number of triangles formed. What's the relationship between this first column and this second one? It's 2 less, right? A 3-sided figure made 1 triangle. A 4-sided figure made 2. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So we could describe it as the number of triangles formed is 2 less than the number of sides. So what we're going to do is write an expression for the sum of the measures of a polygon with n sides. Okay, so like when we had 7 sides, we knew it was 5 triangles, and 5 times 180 is 100. When it was a 6-sided figure, 6 minus 2 is 4, times 180 is 720. So if we have a figure that's n number of sides, you take 2 away, that's how many triangles are going to form times 180. We just figured out the formula for today. That for any polygon with any number of sides, you do the number of sides minus 2 times 180, and it gives you the sum of all the angles. So now, flip over your paper. Hopefully you never ever forget polygon angle sum, because you know that it's the number of sides minus 2, because that's how many triangles. So first thing we have to do is fill in some vocabulary, some polygon names, which hopefully y'all remember. If it is a 3-sided figure, that is a triangle. A 4-sided figure, quadrilateral. 5-sided figure, pentagon. 6 sides, hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon, and 12 is dodecagon. It's a weird word, I get it. Okay, so these are all the polygons that you're responsible for knowing. So on a test or a quiz, if I said, find the sum of the measures of the interior angles of a nonagon, you need to know that a nonagon is a 9-sided figure. So let's just remember or reiterate from the front, the polygon angle sum is the number of sides minus 2 times 180 degrees. So if I asked you to find the sum of the measures of the interior angles of a nonagon, how many sides is a nonagon? It's 9. So 9 minus 2 times 180. So 9 minus 2 is 7. 7 times 180 is 1,260 degrees. That's how many degrees are going to be inside a nonagon. Okay, what if it was a heptagon? How many sides does a heptagon have? 7. So 7 minus 2 is 5. 5 times 180 is 900 degrees. So every single heptagon, every 7-sided figure, if you added up the sum of the angles, it's going to be 900 every single time. So let's look at these figures down here where there's missing angles. So first thing we have to do is figure out, well, how many degrees should be in this figure? So this first one has 1, 2, 3, 4, 5, 6 sides. So let's figure out how many degrees should be in it. So 6 minus 2 times 180 is 4 times 180. So there should be 720 degrees inside this hexagon. So let's figure out the ones that we know. So I'm going to subtract 123. I'm going to subtract 84. I'm going to subtract 142, 130, and this 90-degree angle, right? So 720